Another type of summary statistic that we can calculate are what we call medians and quartiles, or the median and quartiles. And so let's define these quartiles here. The first we'll define is called the first quartile, denoted Q1. And the first quartile is a number that's bigger than about 25% of the other data values. Okay. The median, think of like a highway median. The median is right in the middle. And so the median data value is a number that's bigger than about 50% of the other data values. In other words, it's bigger than about 50%, which means it's smaller than about 50%, so it's right in the middle. The next is called the third quartile, denoted Q3. That's a number bigger than about 75% of the other data values. Okay. Now let's talk about how to calculate the median and these different quartiles. So to calculate all of these, we start off by ordering the data. And that means we're going to line up the data from smallest to largest. And then we've got different cases of how to calculate the median depending on if we have an odd number of data values or an even number of data values. Let's take the simpler of the two cases. First, let's suppose that we've got a set of an odd number of data values. So for instance, here's a set of 7 data values. Maybe these represent systolic blood pressures again. And so the median in this case is the number in the middle. So we're going to go over to the fourth data value. We've got 3 below that, 3 above that. So the median there is the number 121. So that means that about 50% of our data values are less than 121, and about 50% are greater than 121. Now let's take the case where we have an even number of data values. Here in this case we have 6 data values, and so the median is going to be the average of the two middle values. So the data in the middle are 114 and 121. So we're going to take the average of those by adding them, dividing by 2, and so we get a median of 117.5. So this tells us that about 50% of our data values are less than 117.5, and about 50% are greater than 117.5. Okay. Now to find the quartiles, the first and the third quartiles, the first step is to find the median. And then after we find the median, that's going to divide our data up into kind of 2 halves. And then we're going to find the quote-unquote median of each half of the data. So for instance, let's take the case where we have 7 data values. So the median is 121. So now we've got 2 halves, this half and then this half here. Now the median of this half is we've got 3 data values, so we're going to take the one right in the middle. So that'll be our first quartile. Second half of our data also has 3 data values, so we're going to take the one right in the middle, and that'll be our third quartile. So the first quartile of 110 means that about 25% of our data values are less than 110. Third quartile of 130 means that about 75% of our data values are less than 130. Let's take the next example. Let's take the case of an even number of data values, where we've got 6 data values in this case. And so the medians, we're going to take the 2 numbers in the middle, take their average, which as we saw before is 117.5, and then that divides the data up into 2 pieces, or 2 halves each, which contains 3 data values. So the first quartile is 110, the third is 130, and we're all done. Now, with quartiles and medians, we like to draw a picture that summarizes those data values. And this picture is what we call a box and whisker plot. So let's take this example of a set of data with 7 data values. And this set of data had a min of 100, a first quartile of 110, a median of 121, a third quartile of 130, and a max of 160. Now these 5 numbers here are what we call the 5-number summary. Okay. And we want to draw a picture of these 5 numbers, of this 5-number summary. This picture is called a box and whisker plot. So we're going to draw here a horizontal axis, which goes from 110 up to 160, because that's our minimum and our maximum value. We're going to put a point here at 110 or 100, which is our minimum. We're going to draw a vertical line at 110, a vertical line at 121, another vertical line at 130, and then put another point here at the max of 160. And then we're going to connect these to look like this. So this is what we call a box and whisker plot. You see the box here, and then these horizontal lines are called the whiskers. And so this box and whisker plot gives us an idea of the distribution of our data. We have 25% of our data values down here in this whisker. We got 25% in between these two vertical bars, another 25% here, and then another 25% up here in this whisker. So we see that kind of our data is a little more spread out here towards this end. It's a little bit more compacted here in the middle, and then it's maybe a little bit more spread out over here than it is over here. And so that's what we call a box and whisker plot. Now, one thing we can do with a box and whisker plot is to compare two different samples. And so here we've got two different box and whisker plots. This is for one sample, and then this is for a second sample. And we see that they're plotted using the same horizontal axis. And so we can easily compare these two sets of data. We see that the second set of data is much more spread out than the first set of data. But the first set of data has a higher median than the second. These data values up here tend to be bigger than these data values down here, because this box, which represents a total of 50% of our data values, is a little bit more to the right of this one here. And so these numbers up here tend to be a little bit bigger than these numbers down here, but these numbers down here are a little bit more spread out, actually much more spread out than the first set of data. Now, our last concept we're talking about in this chapter is the idea of outliers. And informally, an outlier is a data value that is far from the other data values. Now, what do we mean by far? I put far in quotes here because what one person's definition of far is may be different than another person's. So to help make this idea a little bit more objective, we're going to define what we call the interquartile range, which sounds like a scary term, but interquartile range, abbreviated IQR, is simply the third quartile minus the first quartile. And then using this interquartile range, we can more formally define outliers. One definition of outliers is that outliers are any value that is below the first quartile minus 1.5 times the interquartile range. Or an outlier is a number that is above the third quartile plus 1.5 times the interquartile range. So, as an example, suppose we have a set of data with a first quartile of 45 and a third quartile of 60. So the interquartile range is simply 60 minus 45, which is 15. And so by our criteria, outliers are any numbers that are below the first quartile minus 1.5 times the interquartile range. That arithmetic comes out to be 22.5. And then an outlier is also a number that's above the third quartile plus 1.5 times the interquartile range, which comes out to be 82.5. So any number less than 22.5 or greater than 82.5 is considered an outlier. Now these two numbers, 22.5 and 82.5, are what the book calls the Tukey fences. Tukey is the name of a famous statistician who lived in the early part of the 20th century. I mention this term simply because it's fun to say the word Tukey